Welcome to week number 2 of ECE 401 Senior Design 1. In this lecture, we're going to look at project management and OneNote. Now, in senior design, the whole goal is to come up with your own custom PCB, kind of like this puppy. This is a circuit that drives a stoplight, goes green, yellow, red, green, yellow, red. Now, in order to do that, you're going to have to go through a couple steps. The goal is we want the project to be successful at the end. The point behind project management is to increase the odds of your project being successful. So project management is really just looking at how to manage projects, how to increase the odds of your project being successful. Now, a project is an activity that has a start date, an end date, and a specific outcome or deliverable. So again, this is a project that we're doing in senior design. It's got a start date, the start of the semester. It's got an end date, the end of the semester, and a specific outcome. Again, I want to have a working PCB kind of like this. Now, some things are not projects. Reading your emails is not a project. It has no specific start date, no end date, no specific deliverable. But your 401 project is most definitely a project. And sometimes project management is needed. Sometimes it's really not needed. If your project is small enough or you have enough design experience, you really don't have to go through project management. It's kind of like outlining your English paper. If it's a short paper, you can kind of outline it in your mind and start writing it right away. However, if it's more complicated, like a textbook, you need to have a little bit of organization. Same thing with projects. If a project is complex, large in scope, large number of people with hard deadlines, then a little bit of organization really helps the odds of your project being successful. And again, that's the goal of project management. Increase the odds of your project being successful. And project management isn't easy. You can actually get a degree in project management. That's an MBA. People make careers out of being good project managers. So have some respect for MBAs. They're really, really useful. If you have an MBA on your team in industry, that's going to help your odds of your project being successful. And to give an example of some projects that really needed project management, one is the James Webb Space Telescope. That project had 1,200 scientists and engineers and technicians spread across 14 countries and 27 states. Something that large, you've got to have some organization to get everybody working together. The F-35 fighter had 125,000 people working on it in over 46 states. TerraPower. TerraPower is designing the next generation of thorium nuclear reactors. TerraPower has over 600 employees. On projects of this size and this scale, it takes considerable organization for the project to be complete, to be successful. That's where you really need project management. In senior design, our projects aren't nearly that complicated, so you don't necessarily need project management. However, when you get to design 2, you'll be given a project that's fairly complicated with a team of 3 or more people with a hard deadline, meaning the end of the second semester because you want to graduate. So in design 2 and design 3, it really pays off to spend a little bit of time getting organized at the start of the project. That's why we're introducing project management in design 1. Again, design 1 is kind of the dry run for design 2 and design 3. In design 1, we'll start with a smaller, simpler project, kind of go through the steps of project management with the hope that when you get to design 2, this will make more sense and you'll have a higher chance of having a successful project when you get to design 2 and design 3. So that's kind of the background on project management. So let's look at the project lifecycle. Any given project usually goes through a given lifecycle. The project starts out with initiation. That's where you start the project. In company, this is usually at the start of the fiscal year when money is allocated to the project. Kind of a sidelight. When you work at a company, know what the date is for fiscal year start. When you hit that date, projects that are funded, you get to work on. Projects that aren't funded aren't worked on. So if you have an idea of something you want to work on, make sure you pitch it to your boss before the start of the fiscal year. That way, if it gets funded, you can actually work on it. project planning. That's when the project manager defines the scope of the project, the time allocated to it, and the budget to complete the project. This also includes the organization of the project. Next is execution. That's when you actually do the work on the project. Along the way, you monitor the project. If necessary, go back, redesign it, change the plans, change the execution. This kind of iterates. Finally, when the project is over, you close the project. That's when you finish off the paperwork and documentation, close the accounts, and release the personnel. Now, this doesn't have to be sequential. The middle three can be iterative, repeat over and over again. But typically, this is how a project goes from start to end. With the project, you'll have a project manager. The purpose of the project manager is to see the completion of the tasks within the constraints of scope, time, and cost. Now, any given project actually has a conflict. I have a limited, the scope, time, and cost all can interact. The scope is what the project is, what it isn't. The time is how much time you allocate to the project, the start and end dates, and the cost is the money that's allocated to it. The job of the project manager is kind of to protect you, is to make sure the project and the budget allocated are sufficient for the scope of the project, and the manager's job is also to prevent project creep. Now, oftentimes people will say, okay, I know what your project is. Can you add this feature? Can you add this feature? Can you do this as well? Well, that's kind of the project manager's job, is to say no. You'd like to say yes, but given limited scope, limited time, and limited budget, there's only so much you can do. The project manager is basically to push back and say, well, if you want to change the project, I need a different scope. I need a different budget. I need more people. It's basically project manager's job is to protect you. If someone prevent other people from trying to increase the scope of the project or change the scope of the project without allocating more time and budget. In terms of the project charter, one way to prevent project creep is to start with a project charter. Now, the charter is probably the most important part of the project. It defines what the deliverables are for the project, what the key elements are for the project, how much time is allocated for the project, and what the budget is. So the very first thing you want to work on is the project charter. That defines the project. When somebody new joins in a project, the first thing they'll want to look at is the project charter. Again, the project charter is probably the most important document in the whole project. When a manager tries to change the scope of the project, meaning project creep, project charter is what defines what the project is and what it isn't. If the scope is changing, it's a new project. Now, kind of a sidelight, everybody at your company is part of the same team. You'd like to say yes. However, with limited time, limited budget, limited number of people, you can't say yes to everything. That's kind of the project charter. If this project has a very finite scope, very limited scope, the work that you do should be related to that scope of the project. If it's outside the scope, it's not part of the project. The work breakdown structure is kind of how you organize the project. The work breakdown structure is once the project is defined, the next task is to split the project into smaller tasks. Kind of a divide and conquer technique, and typically there's 4 different levels. At the top level, there's the project and the project charter. That defines what the project is. Oftentimes we'll split the project into different groups, like mechanical, electrical, manufacturing, sales. Each of those groups will have a list of activities they need to do, and within those activities are tasks. What these different levels do is, eventually what you want to do is wind up at the task level. This is kind of like your to-do list. These are the different things you need to do, and I need to know who is doing what. So if I divide up the task among different groups, different people within the group, each person should know, here's the tasks I have to complete. There's other tasks that need to get done as well, but someone else is doing those. This makes sure that all the tasks that are needed to complete the project are completed, and there's no overlap. I'm not doing the same task by 2 different people. A Gantt chart is also useful in project management. The Gantt chart is really your timeline. If you have a project, it has a start date, an end date, and a list of tasks. The Gantt chart defines what tasks are going to get done in what order, and when you're going to allocate time for those tasks. So for example, in design 1, I've got the requirements, your paper design, you're going to simulate your design, breadboard it, do a PCB layout, build the PCB and test it, and then wrap it up with a poster. All that has to fit within 16 weeks. The Gantt chart kind of defines how to go from the start date to the end date within 16 weeks, and how much time you have to allocate to each one. Now, simulation is kind of fun. I don't want to be spending 14 weeks on simulation. If I did that, I won't get to the other tasks. The Gantt chart kind of allocates, kind of planning ahead, how much time I'm going to allocate for simulation. At some point, you have to say, good enough, I need to go on to the next step. That's what a Gantt chart is for. Now, with that, that's kind of the basic idea behind project management. In terms of techniques for project management, there's many, many different styles. If you go on Coursera, there are over 2,700 different courses on project management. Basically, everybody's got their own way of doing things. All of them are seeking to improve the odds for a project being successful. So there's many, many different versions of project management. We're going to look at 4 fairly popular versions called Waterfall, Critical Path, Agile, Total Quality Management. In Design 1, we're really just going to be using one of them, Waterfall. When you get to Design 2, Design 3, you can use any approach that you want. You just want the project to be successful, but do use some way to organize your project. You do want your Design 2, Design 3 project to be successful. For now, for this class, we just want to introduce what are different techniques for project management. The first one to look at is Waterfall. The idea behind Waterfall is many tasks can be split up into smaller tasks that are done sequentially. The Waterfall kind of shows how you go from the first task to the second task to the third task. Kind of looks like a waterfall. I'm going to finish the work on the requirements. When those are done, I'll work on the paper design. When that's done, I work on the simulation. Simulate that my design is correct. When that's done, I build a breadboard, make sure my design is correct. Once the breadboard works, lay out a PCB, build, test the PCB, and then packaging. We don't actually do packaging in 401, but in 403, 405 you will. That's what a waterfall technique would look like for project management. That's actually what we do in 401. So the different steps would be the requirements capture. Again, I'm going to define the inputs, the outputs, how they relate, what your project does. For that, I need specific numbers. Like I don't want to have something general like build something neat. That doesn't help my design. That doesn't help with testing. I need something specific. Like on the stoplight, I've got specific requirements. I want to have 3 LEDs, get this turned on, being driven at 20 milliamps, plus or minus 5. I want the green time to be 6 seconds, yellow time to be 3 seconds, red light time to be 6 seconds, plus or minus 0.5 seconds. Those are hard numbers that I can design to. Those are hard numbers that I can test against. That's the requirements. The paper design is basically what you did back in Circuits 1, Circuits 2, electronics. Grind out the numbers. How do you find the values of the resistors, capacitors? How do you connect the components together to meet your requirements? Requirements are all important. Requirements drive the design. So the requirements basically tell you how to do the paper design. If you're stuck with something being arbitrary, like don't know how to calculate this resistor, that's usually a sign of weak requirements. If I just say drive an LED, that's too vague. If I say drive an LED at 20 milliamps, now I know how to calculate the resistance. Once I get a paper design, I'm going to check my design. It works on paper. Does it work in practice? First step is to simulate it. That's using Circuit Lab. I can check my design to make sure it works. If it doesn't work, I can modify it in Circuit Lab until it does work. Currents are within 20 milliamps. Transistors are saturated. Once I get the schematics working, I'll build it in hardware. That's on a breadboard. Once that works, lay out a PCB. to match the same schematics, build and test the PCB, and then if you're in 405, package it. That's how Standard Design 1 is going to run. Now, Design 1 doesn't have to be open loop. I can get customer feedback along the way. That's kind of an agile type of project management. I can get customer feedback or input at the requirement stage, the paper design, simulation. I could be modifying the design as I go along with customer input. That is an option. That's one approach. A second type of project management is called critical path. With critical path, the idea is most projects can be split down into smaller parts. Some can be done in parallel, some have to be done sequentially. An example of that would be the courses you need to graduate if you're a computer engineer. These are the courses you need to graduate, but some have prereqs, like Algebra 1 is the prereq for trig, which is the prereq for Calc 1, prereq for Calc 2, prereq for Circus 1, prereq for Design 1, and so on. Some of these have to be done in a certain order. Critical path says which path is the longest from the beginning to the end, and that's this path right here. What that tells you is if I'm signing up for courses, it's kind of arbitrary when I take some of these courses, but some have to be done in a certain order, and some you really need to be taking. If I don't feel like taking one of the courses along the critical path, then I postpone graduation. On the other hand, if I postpone taking, say, electronics over here, that doesn't really slow you down. If I postpone taking calc or computer science 2, 1 semester, 2 semesters, it doesn't really affect graduation. So a critical path is what tasks are in the longest path to finish. At any given time, I want to be working on some of those tasks. Plus, the rest of them need to get finished before I'm done. That's critical path. That kind of holds in standard design as well. If you break down your project into smaller chunks and arrange those by order that need to be completed, you can see which activities are in the critical path. At any given time, you need to be working on those activities because those are ones that are critical. Those are the ones that determine your end date. If you postpone one of them, your end date slips. Third type of project management is called Agile. Now, this is an iterative design. The idea is to split the project into smaller tasks, then go through the entire design cycle for each task and keep iterating. So I'll do the first crew design, get it working, then improve it, add features. Once that works, improve it, add features. That's called Agile. That works pretty well in Design 2 and Design 3 for some projects. We're not going to be doing that in Design 1. Design 1 is more of a water flow. Step by step, come up with the answer. An example of Agile would be like a stoplight. What I could do is, first iteration, I want to come up with a cell phone app that shows what the stoplight is doing and go through the design cycle. I'm going to have a circuit board, go through the green, yellow, red, talk to your cell phone. Second iteration, I'll have hardware controlled by the cell phone, go through the app. Keep on adding features as you go along. That's Agile. Fourth type of project management is called total quality management. The problem that this addresses is suppose company A is building some widget. One way to do that is have the hardware group come up with a design. When they're done, throw it over the wall, give it to software. The software group then takes the design, runs the software throw it over the wall, give it to manufacturing. That all sounds good on paper. What usually happens, though, is when software gets the design from hardware, they look at it and think, well, we can't work with this. So they redesign the hardware and then write the software. When it gets to manufacturing looks at it and says, well, I can't work with this either. So they redesign the hardware, rewrite the software so that it can be manufactured. So you're basically redesigning it multiple times. That's rather inefficient. One way to avoid that is get everybody involved up front. When you start the project, have somebody from hardware, somebody from software, somebody from manufacturing in the room, come up with a design that's going to work for everyone. Once you come up with a design, then design the hardware, throw it over the wall. That design should work for software. They write the software, throw it over the wall. That should work for manufacturing. That avoids some of the rework. That's called total quality management. And the whole idea is to come up with a design that's right from the start. And the hope is that you won't have to redesign the project each step of the way. Now, in terms of Standard Design 401, we're going to be using waterfall. You've got the different tasks, basically the different homework sets. You do homework 1, then homework 2, then homework 3, and so on. When you get to 403, 405, there are other ways of doing it. So that's kind of the idea behind project management. The whole goal is to increase the odds of your project being successful. The second thing to look at today would be your design notebook and Microsoft's OneNote. Now, design notebooks have had different uses over the years. Essentially, your design notebook is your diary. It's where you keep all your records. It keeps your ideas. It's where you record what your ideas are, how you tested them, what the results were. And design notebooks are very, very old. Leonardo da Vinci, for example, kept extensive design notebooks for his work. This is one example of it. The purpose of the design notebook is to help organize your thoughts. That's one of the techniques my advisor had when I was working on my PhD, saying if you're stuck, write up what you have. When you write it up, it forces you to organize your thoughts. Then you can see where the holes are. Your design notebook serves as a reminder. If you ever want to go back and refresh your memory as to what you were thinking, what you tried, what the results were, all that information is in your design notebook. They also help your successor. Someday you're going to get promoted at a company. The person that takes over where you left off, it would really help him or her if they actually had some records of what you were doing. That's your design notebook. So design notebooks are kind of a courtesy for the person that follows on after you. They can also be used in the patent process. Now, a patent, design notebooks used to be really important for patents. Patent is a type of intellectual property that gives the owner the legal right to exclude others from making, using, or selling an invention for a limited period of time in exchange for publishing and enabling the disclosure of that invention. Patents are issued by the U.S. Patent and Trademark Office, USPTO, and they're used in industry to prevent competitors from stealing ideas. Kind of a sidelight. Patents do not allow you to make, use, or sell an invention. What patents do is they block other people from doing so. That's kind of a subtlety. The reason they do that is because it avoids conflicts. If, hypothetically, the patent office gave 2 identical patents, there is no conflict. Patent A blocks patent B blocks patent A. That's not a conflict from the patent office's standpoint. What that means is that if I have 2 identical patents, those 2 companies have to work together to come up with a way to allow allow the other to use the idea. The patent office actually has a very friendly website. If you click on it, I can see patents free of charge. I can do a patent search. For example, if I search for the word talking football, at the date that this was made, there were 3,624 different patents related to talking footballs. I can see the patent, preview it, I can download the actual full patent, who it was issued to, how many pages are in it. You have access to all the patents. Click on it, you can see what the patents are. For example, here's one talking football. It's got the name, the date, the patent number, description of it. So patents are free and available to anybody with access to the web. Patents are also, well, the U.S. Patent and Trademark Office is actually very egalitarian as well. Anybody can file for a patent or a trademark for not a lot of money. Trademark has a one-time filing fee of $250. If granted, the trademark lasts for 6 years and can be renewed. Hiring lawyers for a bulletproof patent does cost more, but individuals are more than welcome to submit patents on their own. Patents can be revoked. Revoking a patent means it's null and void. This is usually done if it can be shown that an invention was used prior to the patent, or the invention is obvious to an expert in the field. For example, it's sort of a fad to try to patent the wheel. That's something that people do continually. They try to sneak the wheel past the patent office. In 2001 in Australia, a wheel was patented as a circular transportation facilitation device, meaning a wheel. That's just kind of a game people play. The owner technically owns the wheel, but if they ever try to enforce that patent, it would be revoked because the wheel was used prior to 2001. It's just kind of bragging rights. Can you sneak something past the patent office? In terms of who owns the patent, it kind of depends. Prior to 2019, the patent went to the first person to bring the device to practice. That was very friendly to engineers. It didn't matter who filed for the patent. The first person to actually get the patent, first person to bring it to practice, gets the patent. That's why design notebooks were so important back prior to 2019. That was your documentation that you were the first to get it to work. So what design notebooks looked like prior to 2019, the design notebooks were actually legal documents back then. The design notebook had to be hardbound, so you can't insert pages, you can't take out pages. Each page had to be numbered. The writing had to be in ink, so you can't erase it, change it. Each page had to be signed, co-signed, dated. Because this is a legal document, it was going to be used for patents, proving who was the first to bring it to practice. Example of that would be the laser. The laser was awarded to Towns in 1959. For 18 years, Towns, meaning the company that he worked for, owned the patent for the laser, and anybody wanting to get use of the laser had to get permission, i.e. pay royalties to Towns or his company. Well, that was changed in 1977 when the patent for the laser was reassigned to Gould. Gould had a design notebook dating back to 1957, showing that he was the first to bring a laser to practice. It made no difference who actually filed for the patent first. The first person to bring it to practice was the one that got the patent. That's the way the world worked prior to 2019. After 2019, the law was changed. Industry did not like the first to drive to practice because it provided uncertainty. For example, the laser, they didn't really know who owned the patent, and it could actually change in the future. If somebody had a design notebook prior to 1957, showing they brought the laser to implementation first, they would get the patent. Companies don't like that. They want to have certainty. So in 2019, companies lobbied and actually did change the patent law from first to drive to practice to first to file. This provides certainty, which is good for industry, but it's kind of bad for engineers. It means your boss can take your invention from you. Whoever files gets the patent. It also means that design notebooks are no longer legal documents, so electronic documents are now okay, meaning that we can now start using things like PowerPoint, Word, OneNote for your design notebooks. Which brings us to Microsoft OneNote. In senior design, we use OneNote extensively. From one standpoint, OneNote is just one option for electronic notebook. It works really, really well for senior design, however. It's easy to use, easy to read, very versatile. I can include text, photos, Excel, files, videos. It's collaborative. I can have people living in different cities, different time zones, different continents, all contributing to the same document, or in senior design. I can have two different students in the same group working on the same document. So OneNote works exceedingly well in senior design. It's good for groups. Each student has access to the same OneNote document. Each student can add material. Each student can see what the other people are working on. It's easy to see your previous work. In senior design, you can see homework set 1, homework set 2, homework set 3, requirements, paper design, simulation results. If you want to go back and see what you did, it's easy to go back and refer to it. It also helps with grading. All that Jeff and I need to do is get a link to your OneNote document. We can go straight to that document and see what what you did on homework set 1. It also is really nice at the end of the semester. Your final report is your OneNote document. We used to have a 50-page report due at the end of the semester. No longer with OneNote. Your OneNote document is your final report. So basically, OneNote works really, really well for senior design. So each group is going to be required to have a OneNote document. That'll be your documentation for Senior Design 1. This will also be used in Senior Design 2 and 3. In Design 1, we'd like you to split your work into different sections. The sections are basically the homework sets. Pages within each section will have things like the project description, contact information, project charter, requirements, Gantt chart, and so on. Throughout the semester, you'll be modifying and adding to your OneNote document. And it's also perfectly okay in this class to go back and revise previous work. Jeff and I will be regrading the sections throughout the semester so that if you only got like 3 points out of 10 on paper design, modify it, improve it, try to get 10 points out of 10. Your homework assignment for week 2 is to create a OneNote document. Now if you go to Bison Academy, under week number 2, here's a sample OneNote document. If you open that up, this is kind of what OneNote looks like. What we'd like you to do is create a document, share it with the different members of your group, have the sections basically be the homework sets. What you'll be doing throughout the semester is filling these in one by one. Once they're all filled in, you're done with Senior Design 1. That's also how we'll be grading it. We'll have access to your OneNote document. Jeff and I will then go in and check on homework set 4. When that's due, do you have the different parts in there? So for homework set number 2, your goal is to create a OneNote document, one document per group. Both people in the group will be using the same document. Call your OneNote document ECE 401 with the term and the group number. Add sections for each major activity, meaning homework sets, and share your OneNote document with each member of your group and your instructor. So that's week number 2 for Senior Design 1.